right, about the function and the graph. Right now we're going to deal with the most difficult section of that. It's called transformations of functions. Transformations of functions. We're going to move around. What does that mean? All right, now transformations of functions. After this class, you should be very familiar with this. Okay, so let me give you one example. Y equals x squared. It's a function, isn't it? All right, so f of x, that's y, is x squared. Can you graph it? You say, yeah, of course. I know how to graph that. I go x from -2, -1, 0, 1, 2, and I can get a y. Y is just x squared, so I get a 4, 1, 0, 1, 4, isn't it? All right, so I'm going to use my little tape. I'm going to use this. Gosh, I still don't know how to get rid of this. Sorry. Here. It's better. It seems like the lights are not there anymore. If I move, no, I gotta move this way, I think, to get rid of that. Anyway, okay, never mind. Okay, just ignore that. Okay, it doesn't really exist. All right, so when I graph, let me get this one. Okay, so this is my axis. Here's a 0 and here's 1, and this is my y-axis. I'm so sorry that you cannot see. Okay, I do it there. All right, now when x equals -2, y equals 4, so I get here, here's 1. And when x is -1, y is 1, I get this point, and then 0, 0, 1, 1, and a 2, 4, and of course I know 3 and 9, right? So I should be able to, I know that, I just know it. All right, can I graph it? Yes. Did you remember I asked you to do this to make it a little flat, so I don't want a sharp turn. So a little flat, then go up and try to connect. Try to connect all the points. Okay. Yeah. I'm sorry. Okay, just ignore my mistake. All right. So this is y equals. Switch here. Is that y equal f of x equals x squared. Okay, now I'm going to ask you to do another one. I ask you to write another function. I'm not using f anymore. I use a g of x. That is, it's also y, so that is x squared plus 4. How do you graph this? Again, you're going to put x -1, -2, 0, 1, and a 2, right? Okay, so I'm going to write it. This is my f function. And then for g, I just do this quickly, okay? For g, when x equals -2, x squared is 4. 4 plus 4 is 8. So I should have a -2 and then 8. I get this point. And then when x equals -1, I got a -1 squared is +1 plus 4. I have a 2, 3, 4. I have 5. And then when x equals 0, I get a 4. Okay, when x equals 1, I get a 5. When x equals 2, I get a 8. Is that 8? It's a 4, 8 here. I have this 5 blue. This is green points. Okay, you might notice something here. These two curves, this is a G curve, and these two function graph, they have exactly the same shape, isn't it? What is the difference is every time after you do x squared, you plus 4, you get a g, which means once you have all those points, okay, then you shift up by 4, isn't it? So that's shift up by 4. If I ask you to do x squared plus 4, this is called transformation. All right. So are you ready to do more? Okay, so I'm gonna let you do f g, then I'm gonna ask you to do h, another function, okay? H of x equals x squared minus 2. Again, I'm putting these x value, -2, -1, 0, and a 1, and a 2. So when I'm putting x equals -2, I get a -2 squared. It's a 4 minus 2. So that should be here. Okay, -2, +2. And then when x equals -1, -1 squared is +1, minus 2 is -1, so I get this point. And when x equals 0, I get a -2. When x equals 1, I get a -1. When x equals 2, +2, I get a +2. If I connect those points, what do you see? That's my h function. So that is from this black function, and then I drop down by 2, right? Because see the points here? See that 1, 2, 3, 4, 5 points, all the way drop down by 2, just drop down by 2. You see that? So that's called a vertical shift. Okay, so just move up or down. This guy, I should use this guy. I use this little black to show that this is called the parent function. Okay, because this doesn't have all those fancy numbers and stuff. It just shows the function itself. It's the square function. So this black curve is the parent function. And if you go x squared plus 4, you just shift up by 4. X squared minus 2, you just shift down by 2. So far, so good. All right, so I'm going to do the next one. J, another function, which is -x squared. What do you think? When x equals -2, you take negative of it, you get a +2, so you get 4. When x equals -1, you get this. When x equals 0, you get that. So we have the j. It's the same as our f. Okay? Nice. Basically, what I'm looking for is, for this x, I need to mirror image that, right? Okay, hij. Okay. K of x. Excuse me. Equals 2 x squared. What it says is this. Every time you get x, you square it, and then you double it. Sorry, let me get a different color. Already used several colors. Okay, so I gotta use this blue color. When x equals -2, when I do square, I get a 4, but when I double, I get a 8. When x equals -1, I square it, you get a +1, and then you double it, you get 2. 0, you get a 0. 1, when x equals 1, you get a +2. Okay, and when x equals 2, you get a 2 times 2 squared, which is 8 here. All right, now this is my blue curve. It's confusing, huh? So that is my k. Okay, what it says is this. From the parent function, the black function, because it's already messy. Okay, from the black function, every time you have, starting from the parent function is x squared. But if you have a 2, what you're doing is you're stretching. See, you double it. See, 0, it doesn't change, but 1 becomes 2, and a 4 becomes 8. You see that? You stretch. You see that? So when you have a 2 here, you stretch by a factor, stretch vertically by a factor of 2. All right, now I think I should erase a lot of things because it's confusing. Alrighty, so let me just go back to my original parent function. Okay, and then I'm going to ask you more. So this is a k, h-i-j-k-l. I do l. L of x is negative 2x squared. Now, oh, I'm so sorry that I already erased my k. So my k of x is this guy, and I stretched it. Let me just do it. I stretched by a factor of 2, so that is my it's not pretty. That's my k. And then the next one is L. L is negative of that. Negative y means it's a positive y, then we're going to flip it down to negative y. Okay, so what I'm saying is it's going to go like this. Okay, so what it says is this: from the parent function, if you have a negative 2x squared from the parent function, what you're doing is you vertically stretch by a factor of 2, and then you flip along the x-axis. So change all the positive to be negative. That's your L. Good, huh? Okay, now mx is 1/2 x squared. Do you remember that when we do 2 times x squared, we stretched by a factor of 2? We stretch by a factor of 2. If it's a 1/2, that means we are going to take 1/2 of it. So when x equals 0, it's still 0, and when x equals positive 1, it becomes 1/2. When x equals 2, 2 squared is 4 over that is here. Similarly, I got this. So that's my curve. And this is m. So what it says is from the parent function, if you have a factor before that is 1/2, what are you going to do? You're going to press it down. Press it down towards the x-axis. Press it down or compress it by a factor of 1/2. Okay? I think right now I can erase this. I can erase everything except my parent function. But I would ask you, okay, let me just do it again. It's my black. Oh, here I just dropped it. Okay. Yeah. Okay, so that's my f. It's my original function. I already did m. I'm going to give you n. N of x equals 3x squared. There are 2 ways to do it. Okay, one way is you make it to be 9x squared. Can you do that? Yeah, 3x squared, which is 9x squared. So what it says is for the n, you just use the parent function. You use the parent function, and then you're gonna stretch vertically by a factor of 9. Can you do that? You can just, so when here's a 0, that's stretched by 9, which is also 0, but here is 1, so it goes to here. Okay. Of course, when it's a 4, x equals 2, that is used to be 4, but you have to times 9, which is 36. I don't have enough space for that. But anyway, yeah. So that's my n function. That's one way to do it. That's one way to think. The other way is, because this is a number, a factor right before x. Now, when x before that is a 3, what you're doing is you're going to compress your graph towards the y-axis by a factor of 1/3. You compress it. Okay, so that's n. One more. Oh, I think I can erase this. I don't really need this for my next part. Okay, you had fun? P of x, I don't think so, is x minus 1 squared. Now this is hard. All right, now P of x equals x minus 1 squared. So let's see what happened when x equals negative 2. When x equals negative 2, negative 2 times minus 1 negative 3 squared, we get a 9, so which is here. When x equals negative 1, so that's negative 1 minus 1, which is negative 2 squared, so that's a 4. Okay. When x equals 0, 0 minus 1 negative 1 squared is here. Okay, and when x equals 1, 1 minus 1, hey, that is 0 here. When x equals 2, that's 1. If you like, you can try another one when x equals 3. 3 minus 1, 2, 2 squared is a 4. All right, now when you graph, it looks like this. What do you think? What's the relationship between your function p and your original function, parent function f? You're shifting the parent function's graph to the right by 1. So when you see x minus 1, shift to the right. Okay, one more. I ask you to do this. Q of x equals x plus 1 squared. Can you imagine? That would be shifting the parent function graph. Here is a plus 1 after x, so you're going to shift to the left. Just very opposite. Shift to the, this is your Q. All right. Oh, I think I'm done. Okay, so I'm done with this. And then we're going to come to the conclusion. Whew. We're going to come to the conclusion. I don't need any more color. All right, the conclusion is this. Parent function. It's interesting that they call that parent function, isn't it? Okay, that's okay. Parent function. F of x. Okay. And then if you have the new one is y equals f of x from the parent function, you plus c, you plus a number, which means you're going to move up by c. Okay? And then if it's y equals f of x minus c, means you're going to move down by c. Remember, f of x equals x squared. If we plus 5, then we just shift up by 5. Is minus 1, we just go down by 1, right? So that is called the vertical shift. And the horizontal shift is this: y equals f of, instead of putting the c after the function, I changed the x. So here is x plus c. Okay, now this one, be very tricky. If it's a plus c, you think a plus is to the right? No, if it's related to x, you're going to shift to the left by c. And very similar, if you have x minus c, then you shift to the right. horizontally by c. Okay? All right. Now, if y equals negative f of x, you're going to flip along the x-axis. If it's a y equals f of negative x, then you're going to flip along the y-axis. Okay? And then the next one, if it's y equals c times f of x, the parent function comes with another number before that, and here we have the c is greater than 1, then we're going to do what? We are going to stretch by a factor of c, vertically, stretch vertically, up and down, right? Vertically, stretch vertically by a factor of c. But if it's c, if c is less than 1, like 1/2, so we're going to shrink vertically by a factor of c. Okay, so c is like 1/2. All right, so one more. It's too much. It is too much. So if we have a y equals f of cx, there's a number before that, and we have a greater than 1c, then we're going to remember, for the changes in x and y are quite opposite. So this one with c is greater than 1, we're going to stretch. Here we're going to shrink. We're going to shrink horizontally by a factor of what? 1/c. Or shrink by c. Oh, you can say that. Or you can shrink by. Okay. And if a c is less than 1, so it's 1/2, then we're going to enlarge. We're going to stretch horizontally by a factor of c. Well, I'm tired already, but this is something that I hope that you can take a little note. Okay, so that has everything. It's a parent function, and then what's the change? And there's a page, but if you don't have it, I think I just make it like in one page, and if you like, then you can see the transformation of a function. That's called the transformations of the function. Okay, so but anyway, okay, nothing will compare the real example. So I already know like so many things. If I give you a function, whatever function, then you can just use what we learned to do the transformation. So what about f of x equals absolute value of x? That is this. When x equals positive, when x equals a positive number, then it's the same as y, so it's a 45-degree. And this is that. That's a graph, right? So what about this one? G of x equals absolute value of x minus 4. Okay, without telling you this, if I just ask you to graph this parent function. Remember, the parent function is the one without this and without the factor right in front of that x. So if we know this is the graph of the parent function, and then starting from the parent function, we're going down by 4. So 1, 2, 3, 4. Therefore, that's my f, that's my g. Alright, so from the parent function, we go down by 4. That's easy, isn't it? Next one. I ask you to graph g of x equals the square root of x plus 5. What is the parent function? First question, what is the parent function? The parent function f of x should be just the square root of x. What does the function look like? If it's just the square root of x, that x, the domain of this function, has to be either 0 or positive. So that's from 0 and 1, okay, and then all the way to positive. There should be nothing to the left of the y-axis. Okay, so the function look like this. When x equals 1, square root of 1 is 1, and when x equals 1, 2, 3, 4, and then that is 2. Square root of 4 is 2. Okay, so it looks like this. That's my f. Now, what happened to this? The g function, which is x plus 5, remember, it's not that straightforward as the y change, right? Now, right now it's x plus 5. You think plus 5 to the right? No, wrong. Should shift horizontally to left. So here's 1, 2, 3, 4, 5, starting from here. So your graph, the new graph will look like this. And that is g. So you have to shift to the left by 5. Here's a negative 5. Okay. Next one. Oh, did I put something here? Sorry, it's a mistake. All right, now the next one. Can you graph h? I can just use any letter to show a function, isn't it? And that is x plus 1 square minus 3. Now this is complicated. Parent function. Parent function f of x, just x squared. And we know what the parent function look like. The parent function look like this. Here's 1, here's 1, here's a 0. It's a little more. So I just do this very quick, okay? So if here's 2, then that's 1, 2, 3, 4. I have to pass these points. That's my f. That's my parent function. It looks very ugly. I should do it like this. Okay, forget about that. Okay, so that's my parent function. Now, what about h? Okay, the tricky part is always identify where is your x. Where's your x? It's right here. Okay, what you should do is you should plus 1 first. That means if x becomes x plus 1, you're going to shift it to the left or right? Left. Okay, because a plus 1 means positive 1, but you have to shift to the left. So you're going to shift to the left by 1, and everything shift to the left by 1. So you're going to do this, right? And then after you do this, the parent function work, minus 3, so you have to drop down by 1, 2, 3. So basically you're going down here. You have to do left by 1 and then down by 3. So that is your new graph. That's my h. Make sense? So to the left by 1, to the left by 1, and then down by 3. That's how you should shift from your parent function. Okay, one more. I think we have to do a couple of more. So I ask you to graph g of x equals negative cube root of x. What is the parent function? F of x is, forget about this negative, it's just the cube root of x. What the cube root function look like? Probably you don't know, but I tell you. Looks like that. That's your f. All right. Now what about the g? Did you notice that every time you work with your parent function, you have to change the sign? to get a y, so which means this. That's your g. Okay? Now you're starting having fun, huh? I don't know about that. So next one. Can you graph h of x equals the square root of a negative x? Parent function. F of x is just the square root of x. And we did that. Square root of x looks like this. That's your f, right? Remember? And what about here is a negative? That means you're going to flip along the y-axis. So this is your, h. I just about to say g. No, it's h. Okay. More. I ask you to graph h of x is 1/2 times x to the third. I tell you this. Parent function equals just x to the third. It looks like this. That's my f. What about an h? H is 1/2 of it. So after you do x cubed, you always do half, or you multiply by 1/2, which means your y will shrink by 1/2. So which means you're going to compress it. So this, like half of the height, and that is your h. Okay, isn't it interesting? More. I think we're starting having more fun. All right, next one. I give you a graph. I didn't give you the function, okay, because it's too complicated to describe it. So I do the graph. It looks like this. All right, so this is f. Interesting. Okay, now I ask you to do this. I ask you, can you graph the g of x equals f times f of 2x? Remember, every time you work with this x, it's quite opposite than you think. If it's a y, or you just multiply by 2, then you just vertically stretch by 2. But this one you have to horizontally squeeze by a factor of 2. So I want to use different color. So you squeeze towards the y-axis. So half, half, half. That's my G. What do you think? It's really cool, isn't it? Okay, one more. H. H of x equals f of 1/2 x. Can you graph it? Again, that works with this x, and it's 1/2. So it's not shrink by 1/2, it's enlarged by 2. So it's going to do stretched horizontally by a factor of 2. So it goes from here, and this by 2 goes here. It should go here, and this by 2, this by 2, and this by 2. Oh, sorry, I should go with this, the black curve. So black goes here, and this one goes here, and this one goes here. Oh, more here. So I got, it's much more flat. That's my H. So you like it? Ha. Last one, I promise you. This is our last one. So we have, I give you the y equals f of x. Can you describe how you get this graph? It's a negative 1/2 f of x minus 1 plus 3. So I ask you what you should do. What's the transformation you're going to perform from the graph of the f of x? Okay, I tell you, always identify where is your x. So here is the step you should do. So starting from parent function, first of all, x minus 1, you have to shift horizontally to right by 1. That's the first thing you have to do, isn't it? Okay. After you do this, and then you work with this 1/2, which means you're going to shrink vertically by a factor of 1/2. So you press it down, you shrink by 1/2. But don't forget there's a negative sign, so you're going to flip along the x-axis. Okay, so you did this, you did this, you did this at the last step. So you're going to shift vertically up by 3. Okay, it's complicated. Okay, by 3 or 3 unit. So I told you I promise you this is the last problem that we're going to work on. So now you see that what you should do is you always find where the x is. Starting from here, this is the parent function, so that keeps the shape. And then what you should do is you work on this, you shift to the right by 1, shrink by 1/2, flip along the x-axis. The last step is a +3. Last step is go up by 3. Phew. Okay, I think that's a lot for today.